What it is, here you is on the last homework lecture of the unit, Intermolecular Forces. Up until now, we've only looked at how do single or double or triple atoms combine. They either transfer electrons, become ionically charged, and make an ionic bond, or they share electrons either unevenly or evenly to make a covalent bond. The next question is, okay, I got these compounds versus molecules. What happens if I have like a bunch of the same molecule? Do they interact with each other? The answer is yes. And intermolecular forces are the ways in which they do. Okay. There's only two that you really need to know about, and let's hit them up. Intermolecular forces, IMFs is how we abbreviate it as chemists. These are forces of attraction between molecules. They're not really bonds. If you think of them like magnets, if you think of a molecule like a magnet like I do, then you can handle understanding what an IMF is. It's when you get one molecule or one magnet close to another magnet and it starts affecting it, right? You put one magnet next to the one and it starts to spin the other one. So they can feel each other from a distance. That's what an intermolecular force of attraction is. It's not really a bond. It's just you can feel the other molecule from a distance. And here's what the IMF attraction between molecules are. It's the positive end of one molecule is attracted to the negative end of another. So just like the north end of a magnet is attracted to the south end of another magnet, molecules do the same thing, except we call them partial positive and partial negative because of the distribution of electrons. If it's one side of the molecule's got more electrons, we call it partially negative. The other side of the molecule's got less electrons hanging around it, call it partially positive. The larger the IMF, the higher the melting points and boiling points. These are for covalent molecules only, but the more the molecules are attracted to others of their type, the more sticky the molecule is, the more energy it takes to split them up, which means the higher melting point and higher boiling point of the substance in bulk. Here's a name: van der Waals, dipole-dipole, and hydrogen bonding. Van der Waals forces are very, very weak. These are like nonpolar attractions, so like two hydrogen molecules. Every now and then they'll line up in a way where one end is attracted to another end, but it's for a trillionth of a billionth of a second, and it doesn't amount to much, which is why van der Waals forces are very, very weak. Dipole-dipole forces. These are weak compared to actual bonds, but they are stronger than van der Waals forces. So when you have two polar molecules, they might be the same or they might be different polar molecules. Each molecule has a positive and a negative end. So the poles attract. And they're constant, so they increase that attraction. So I got one polar molecule, it's going to attract to another polar molecule, and they're going to want to try and stick together. They're not actually going to bond, and it won't take much energy to split them up. But they are attracted to each other more so than if they were both nonpolar molecules. Okay? Now the most important one to me is hydrogen bonding. This is a specific type of dipole-dipole force. When the dipole is between the hydrogen atom, which is the positive part of a molecule, and the nitrogen, oxygen, or fluorine, which is the negative portion of a molecule, of another molecule. So hydrogen bonding is relatively strong because nitrogen, oxygen, and fluorine are extremely electronegative. They will attract electrons to their side of the molecule, so much so that they have a cloud of electrons on it that hydrogens from other molecules want to get with. That hydrogen from another molecule is being stripped of its electrons. It's very positive. It says, I need electrons. Oh, look, there's a big old cloud of electrons over there on nitrogen, oxygen, or fluorine. Let me get close to you. I know I'm not going to actually get any of them, but just let me get close to you. And that's what hydrogen bonding turns out to be. It is not truly a bond, but it is the strongest of the intermolecular forces. Hydrogen bonding in water is the reason why water has a relatively high boiling and melting point compared to other polar molecules. And here's some notes on that hydrogen bonding. It's responsible for many of water's unique properties. Why does ice float? It's a solid. It should be more dense and fall to the bottom. No, because water's got hydrogen bonding. When water turns to a solid, it actually expands a little bit because the atoms actually get more organized when they form this particular crystal. It's not because they're holding on to little air bubbles in there and floating. It's because the molecules actually spread out a little bit when they turn into a solid, unlike other compounds which get closer together when they turn into a solid. There you go. Relatively high melting point and boiling point. You might not think 0 degrees Celsius is a high melting point, but compared to other nonpolar substances, it actually is. And other polar substances too. It's actually a pretty high melting point compared to. And the boiling point being 100 degrees higher than the melting point is almost unheard of for nonpolar and polar compounds. Usually the melting point and boiling point are much closer together. But since those water molecules is sticky, there's a bigger difference between the temperature on when it would melt and when it would boil. Liquid ends up more dense than the solid form of water. It's a good thing because otherwise all them fishies in the oceans and lakes and rivers would get crushed when winter rolled around and we wouldn't have anything to fill out the bottom levels of our food chain. And that's about it. 27, 28, 29 are legitimate practice pages for you to try. You're going to need a periodic table, and the Google Classroom assignment is going to back it all up. So that's the whole unit, except for your little adopt a compound project. And I hope you can keep up your end of the deal. Do those practice pages ahead of time. Prove to me that you are worthy of autonomy, and you might just get a chance to do the next unit at your own pace as long as you make certain deadlines. Hasta la pasta.